All right, welcome back. We're just going to take care of a couple of short things here, dealing with parametric equations. And what we're going to do is talk about working with the equations more themselves. And we're going to do two things. One a little bit tougher. I'm going to show you guys how to do what's called eliminate the parameter. And then one that's a little bit easier, in fact quite a bit easier, called introducing a parameter. Okay, so just to show you some examples of how this works, if I were to give you a pair of equations written in parametric form, meaning x is equal to 5t minus 1, y is equal to 2t plus 5, x is in terms of time, y is in terms of time. And I wanted you to eliminate the parameter, meaning I want you to rewrite the equations without time. What we do is, number one, solve one of the equations for t. Just as an example, there's more than one way to do this, but as an example, I could take the first equation, x equals 5t minus 1, and solve for time. Moving negative 1 to the other side by addition, and then dividing everything by 5. So time is equal to 1/5 x plus 1/5. Okay? And then what I could do is substitute into the other equation. So wherever I see a t in the other equation, I could replace t with what it's equal to. So if I replace t with 1/5 x plus 1/5, and just do a little bit of simplifying, a little distributive property, 2 times 1/5 x, 2 times 1/5, and add the two numbers together, 2/5 plus 5 is 27/5. What we get is an equation that doesn't have a t time element in it any longer. So what we've done is we've taken the pair of parametric equations and I've eliminated the parameter. I've removed the t. And you can tell that the original parametric equations actually represented a straight line. We get the same graph no matter which direction you go, but I'm just showing you that you can, if you need to, eliminate the parameter. Okay, let's try that a couple more times. This one again is fairly easy, and then we'll finish with a tougher one. So we start with x equals the ln of 9t and y equals t squared. And what I'm going to ask you to do is select one of the equations, select one of the equations and solve for time. So as an example, if I select the first equation, x equals the ln of 9t, gosh, that's messy. Let me write that a little nicer, guys. Ln of 9t, what I could ask you to do is solve for t. Okay? Well, how do you get rid of, or how do you solve for t when it's part of a logarithm? Well, the answer is you have to take the inverse. So we'd have to take the inverse, and the inverse of a logarithm is an exponent. Now, whatever the log base is, that becomes the number base. So that means we'll then have e, because ln means we automatically have base e, raised to the x equals 9t. And if I get rid of the 9 by multiplying both sides by a ninth, what I'd have then is t is equal to 1/9 e to the x. Okay? And then all I have to do is simply replace or substitute t in for the second equation. So instead of y equals t squared, I'll have y equals 1/9 e to the x squared. And I'm just going to choose to get rid of the parentheses so you guys don't have to work with them. So I then end up with 1/9 squared, which is 1/81st, and e to the x squared, which is e to the 2x. Okay? And so we end up with an equation that does not have any t's. We started with parametric equations, equations that had a t. We end without a t, so we say that we eliminate the parameter. Okay? Now the last one's going to look a little bit tougher. Oh, by the way, the first one we did, you can tell obviously that we ended up with a straight line equation. I'm not sure if you could tell when I gave you the parametric equations if you would have recognized that it was a straight line. Second example, if when you look at the original parametric equations, would you have recognized that that's an exponential? Probably not, but it's clear at the end that it's an exponential because you see the variable in the exponent, so it's an exponential. So the challenge question on this third example would be, what kind of graph would we have for these two equations? X equals 1 over t plus 1, and y equals 3t squared plus 6t plus 4 over t squared plus 2t plus 1. What is that going to be? Very, 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 very difficult to understand what the graph would represent. But that's not the key right now. What I want to do is I want to eliminate the parameter. So I'm going to select one of the equations. I'm going to choose the first one, and I'm going to solve for t. I'm going to solve that fella for t. Okay? And so to solve for t, I'm going to think of x as being a fraction and cross multiply. So if I cross multiply this way, what I'd have is x times t plus x, and going this way I'd have 1 times 1. So to solve for t, I'd need to move plus x to the other side by subtraction, right? And then divide both sides by x, so that t is equal to 1 minus x divided by x. Now, wherever I see a t, and unfortunately, that's quite a few places, everywhere I see a t, I've then got to replace it with 1 minus x over x. So what y then becomes is 3 times 1 minus x over x squared plus 6 times 1 minus x over x plus 4 divided by 1 minus x over x squared plus 2 times 1 minus x over x plus 1. All right? And what I'm going to challenge you guys to do is simplify that. I'm going to challenge you to simplify. Right? Some of it's not so bad, but then other parts a little bit tougher. As an example, the first part is pretty tough. 1 minus x over x squared. I know you're not going to have an issue with the denominator. That'll just be x squared. But the numerator, we'd have to square a binomial. So 1 minus x squared, and then distribute a 3. And what we'll get then is 3 minus 6x plus 3x squared. All right? The second one, much easier. We just have to distribute the 6 into the numerator. So 6 times 1 and 6 times negative x. Downstairs, similarly, 1 minus x squared is a binomial squared. So our shortcut, first one squared, first times the second, second one squared. And then in the denominator, we'd have an x squared. Second term, again, a little bit easier, just a little distributive action. 2 times 1. Let's see, 2 times 1 and 2 times negative x over x, and plus 1. Okay, need a little bit more room to work. Right, now what? You might be thinking, oh gosh, he's going to make me do common denominator stuff, but we can get away with that. What I'm going to have you do instead is I'm going to have you multiply top and bottom of the fraction by the same thing. Now, if I asked you to multiply top and bottom by 5, is that legal? Yeah, because I'm really just multiplying by 1, right? 5 divided by 5 is 1, and if I multiply by 1, I don't change anything. But I'm actually not going to have you multiply by 5. Instead, what I'm going to have you do is multiply everything by x squared. So I'm going to have you multiply everything by x squared, both in the numerator and in the denominator. Now what happens when you do the first multiplication is the x squared you're multiplying by and the x squared in the denominator cancel. So you're just going to be left with 3 minus 6x plus 3x squared. When you do the second multiplication, the single x cancels in the bottom, but I'd have an x left that I'm multiplying by, so x times 6 and x times negative 6x. And finally, I'd multiply x squared times 4. That's the easiest one. That's just 4x squared. And then the same thing in the bottom. The x squareds cancel. One of the x's cancels, so I'd be left with 2 times x and 2 times x squared. And then finally, 1 times x squared. Right? Still looks like a horrible mess, but we've got some like terms that we can put together. As an example, up top, 3x squared, negative 6x squared, and 4x squared is 1x squared. Then I've got a negative 6x and a positive 6x. Those just add up to 0. And then I also have a plus 3. All right? Downstairs, I've got some x squareds. Positive x squared minus 2x squared plus x squared is 0x squared. I also have negative 2x plus 2x, which would be 0x. And then I also have a plus 1. And of course, these two fellows just zero each other out. So I end up with x squared plus 3 divided by 1, which is x squared plus 3. And if I shrink this up just a hair, in fact, I'll just shrink it so you can see the whole thing, and then finish off just one thing. I haven't bothered, whoop, I hit the wrong, hit the highlighter instead of the pencil. If I just drop down my y on the left-hand side, you see the equation we get then, the result is a quadratic, meaning the graph of this fella would be a parabola. We never would have recognized it written in parametric form, but when we eliminate the parameter, the graph becomes obvious. Okay? All right. And then finally, to finish off, the other problem that we do with parametric equations is sometimes we have to introduce our own parameter, or sometimes we would want to introduce our own parameter. So if I start you off with an equation that does not have a parameter, does not have time in it, how do we create equations that would be in terms of time? So how would I create x in terms of t and y in terms of t? So what we'd want is t's on the right-hand side of both of those equations. Okay? And how do we get that done? Well, it's a heck of a lot easier than you think. One easy option is just simply to, everywhere you see an x, replace it with t. And if you actually take the equation, y equals 4x minus 3, and everywhere you see an x, replace it with t, we then end up with parametric equations. X is equal to t, and y is equal to 4t minus 3. It can be that simple. Now, there are specific applications when you guys get a little bit older and you're doing some college-level science where you're not just going to make x equal to t, you'd have to make x something a little more complicated. But it can be as easy as that. All right, so that's where we're going to stop. You should be all set to go to finish up the rest of section 5. Like always, feel free to give me a holler if you have any questions. I can try and help you out. Otherwise, enjoy the problem set, and we'll hope to see you guys soon. Have a great day.